Well, hello everybody and welcome back to Revit MEP Ducting Soup to Nuts Part 3, the final installment in this three-part series where we go over just about everything we need to know about ductwork to be successful. First off, I want to start by apologizing for the webinar, the live webinar performance today. We had some technical difficulties there, and hopefully this video that we're posting here is going to plug the gap for us. So again, welcome guys. My name is Don Rasmussen. Senior MEP Applications Engineer here with CAD Technology Center. Today we are going to cover, go down one more slide here, there we go. Today we're going to cover Revit MEP ducting as usual, but the topics for today are pretty much the contextual commands that come up when we either choose to draw with ductwork or we go ahead and select some ductwork that's already drawn in those contextual commands and what they do and how we can use them properly. And then we're going to go through some fitting options. There's some fittings that have been that aren't brand new but have been included in Revit for a little while that a lot of people either completely forget are there or aren't taking advantage of yet. And I want to make sure that I point those out to you and some of the flexibility within those fittings. And then we're going to go over a little bit about slope ductwork. Slope ductwork is possible in Revit. It requires a little bit of a workaround and then some additional thought process to go along with that. But slope duct is possible in Revit for all the people who have to draw grease duct and go ahead and coordinate that inside the Revit environment. So with all that being said, we're going to go ahead and hop into Revit here. And I've got my standard data set that you guys have all probably gotten used to. And I'm going to start off here by coming over to our ribbon, and picking duct. Now, of course, we're all familiar with this contextual area here where we can enter the width and the height, and then the offset elevation here as well. But more and more people aren't familiar with some of these tools and how they work here. During my trainings, I'm consistently running into people who don't use a lot of these tools or take advantage of them. The first tool that I want to talk about is justification. Now, left to out of the box settings, the offset will be centerline for ductwork, and not everybody likes to design that way. Some of us want to design from the top of the duct or the bottom of the duct. So if we use our justification options, we're able to do that. What we can do here is we can set our horizontal justification, so center, left, or right, and we can do that independently from our vertical justification, top and bottom. Again, a lot of this is similar to what you may see inside of the piping commands inside of Revit. The basis for these contextual commands is pretty much the same. And then, of course, a horizontal offset that we can put in there as well. This is good for offsets from walls or from other controlling geometry. I'm going to go ahead and keep everything on middle here just for now. But this is where you can come in and you can change top and bottom of duct. So I'll go ahead and click OK here. Get out of this for now. And then I want to just kind of point our direction to this automatically connect option. This is another just on-off option, but it is something I feel like you should have set. This is the power of Revit, right? This should always be on, so it generates these connections for us. And then we have inherent elevation and inherent size. These are really great options for when you're continuing a run of ductwork, especially if you're drawing just out of the center line, if you don't make any adjustments to the justification. This is a really nice option to keep everything on that same center line, be it a trunk line or a duct run. And inherent size, not so possible obviously for a branch situation, because most of the time those are smaller sizes than the trunk line. Not all the time, but most of the time. And so we can use this one sparingly, usually using it when we need to extend trunk lines or things like that, to go ahead and continue our design. So right now I'm just going to go ahead, I'm going to pop in a piece of ductwork. And I actually should raise this elevation here a little bit. So let's bring this puppy up to 9 feet. And I'm just going to draw this little duct across here. When I come back and I click on this duct, we have other contextual tabs that pop up. Not just modifying duct commands, but also our duct systems commands as well. But we'll go back to the modifying ducts for now. And you'll see here that we can justify this piece of ductwork also after it's been drawn. The justification command control looks a little bit different. Again, this is a contextual tab, so this is all basically done pictorially. So we're going to click in which area we want this justified. So if I want to justify to the top, I simply click the top and I click finish. And now the top has been, now the 9 fit is now at the top of the ductwork rather than the center line of the ductwork. Then of course our lovely cap open ends options. Our cap open ends options are just going to go ahead and look at that piece of ductwork and throw a cap at each end. If I go ahead and undo that, the cap open ends option becomes valid again for us. So obviously if it's capped, we can't cap the open ends. And then we have our insulation commands and our lining commands. I see a lot of people on the contracting side taking advantage of this. Unfortunately, on the engineering side, I don't see a lot of people using this, which would be a big help in the next step on the road, if you will, for the Revit model as it continues on throughout the process. But adding insulation is really simple. You simply select the ductwork, and then you tell it you want to see insulation. You can choose between duct wrap or rigid fiberboard. You can also come out here, edit the type, and you can make additional types of wrap if you would like, with all sorts of different manufacturers. It is quantifiable inside of Revit with schedules. But then we just simply pick the distance here. I'm going to go ahead and pick 3 inches just so the graphics turn out okay. Click OK, and add that insulation to the ductwork. Same thing with lining. So now I can remove this insulation here. That's how I would take it off. Are you sure you want to? You bet. So now it's gone. I can also add lining. Lining is done in the same manner. So again, fiberglass ductboard or textile, we can go out to edit type. We can create any additional pieces of lining that we would like to have. One thing to note though that's different than the wrap would be this roughness value. This will affect your static pressure analytic calcs inside of Revit. So this is a value that you need to set if you're going to run analytics and you want them to be accurate. Say OK here, add the lining. Again, you'll see here once it's I have the option to edit or remove. I'll go ahead and remove that lining for now, and it's gone. Also, I'll click back on this guy. You have your duct and pipe sizing capabilities here. Now, this is basically a ductilator entered into Revit, and it does a pretty decent job. We can set our sizing methods by any one of these options. So equal friction, static regain, velocity or friction, friction loss being over inches of water column. Now, we can do onlys, ands, or ors, depending upon what our sizing method is. And then we have some constraints that we can set up here. We can match the connector size or calculate by size only, or larger of connections and calculated. Then set up any restrictions that we might have here and here, and it should auto size our duct for us. Now this is not going to auto size obviously because there's no flow rate assigned to this ductwork, as you see right here. Once a ductwork flow rate is assigned, the auto sizing should work. That's enough about the contextual tabs there. I wanted to take some time and go ahead and talk about some slope duct and how I've been able to make that work in the past. As you can see, it's inside of my depth box here for my section view. I'll go ahead and double click that so we're looking at this in a section view. And for right now, I'm just going to do myself a favor so no one gets confused. We'll blow those out of there. And take a look at this piece of ductwork. Now, obviously when we go to draw ductwork, we don't have a slope option when we draw the ductwork. However, we can slope this ductwork after the fact and then continue on from there. One thing I have noticed though is that as we slope this duct, I'll just go ahead and pick an arbitrary number. So maybe this is 8 foot 10 inches. We can always come back and adjust the slope value as well if we wanted to go to something specific. So I'll set this to maybe 1/8 of an inch. Now, as with anything sloped, there are certain areas where it's not going to be sloped. So say for example, this is grease duct. This is not going to be sloped, say for example, as it goes into the fitting that's going to turn down into the kitchen hood or turn up into the fan. Those are relatively level. So what we have to do here in Revit is pay attention to what Revit's going to do to us from a design standpoint. Let's go ahead and stretch this a little bit. So at 1/8 of an inch, with my justification, you can see your justification also moves your control points, which is super nice because it reminds you of what your justification is. But if I right click here and I draw duct, and I want to draw a flat piece of duct here, Revit doesn't like that. Can't make the fitting that it wants to plug in here. And this is really kind of a restriction as far as drawing slope ductwork inside of Revit. If you want everything to stay connected, there are some limitations to what you do. So if it's at an 1/8 inch here, and let's increase it to 3/16 here and see if it works. I don't think it will. I right click here, draw duct, and it probably still won't want to make that fitting. Yep. Usually 1/4 inch is the minimum of which you can slope duct inside of Revit, and then it starts to understand, or at least have enough room in its mind to go ahead and place a fitting in there for you. So I'll change this to 1/4. We'll go add on to this piece of duct, and it does add just fine. Now we'll put these fittings in here. If you want to run quantification on the system, even though you know that this fitting wouldn't actually be in there, this would all be black welded duct. All this can be ripped out in a schedule and quantified, but then these have to be accounted for in that quantification. Obviously these wouldn't be fittings, that would be made up for in the joints for contractors, things like that. So really the goal here would be to be able to model in slope ductwork to the point where you can get some of the bigger coordinations ironed out, make sure things fit in some congested areas, as oftentimes grease duct unfortunately is an afterthought in some of the jobs I've worked on. So just to show you guys here, it is possible, you can do it, you can design with it. It is limited though with some of the functionality as I just demonstrated in regards to the slope and how that all works. So we'll get out of this for now, and we'll go take a quick peek at some of these fittings that I have here. Now, the fittings for ductwork have come a long way. I'll start off here in the middle where we have these mitered elbows. Now, the mitered elbows typically need to have turning vanes. Just about every municipality I've ever done work in, and most people I talk to, need to have turning vanes as well. Both of these elbows are the elbows with turning vanes. But I consistently get some calls into our tech line, and people aren't able to see the turning vanes, or they're having some issue with this display. It's important to understand that the turning vanes that are inside of these families are a nested symbol family that's controlled by a general model. So if I go ahead and I come into my view template, go into my visibility graphics, and I turn on general models, then my turning vanes show up. But since it's nested, this is controlled a different way if I want to turn it off. So I can turn off duct fittings and these turning vanes will go away. But if I have duct fittings turned on and general models turned off, the turning vanes do not show. So that's important to remember and keep that in mind. As you can see, you have two different options here from Revit. I'm going to go ahead and switch to thin lines here so it's a little bit easier to see. You have two options. You have the double thick vanes, which are going to show you less vanes, but they're a little bit more prominent inside of the fitting. And then you're going to have the one with just single vanes, which is going to show you more vanes, and then they're a little less prominent when they print. And of course, these elbows auto size depending upon the ductwork that is, or the duct size rather, that is plugged into them. Then if we continue down here a little bit, we're able to see that we've got some extra options from Revit for split vanes. Split vanes being used in ductwork is, again, you're able to do this in Revit. It's prominent here. The symbology is not controlled the same way as it is with these mitered elbows. We don't need to worry about categorical control as much, considering these are all inside the duct fittings category. But you're able to show a one vane, and then there are separate for one split vane, two split vanes, or three splitter vanes, as you see here. So here's the one, here's number two, and here's the three. So depending upon your application, you have different options here to use either one of these or either of these fittings in your layout. Then I'm going to go back up to the top here and I'm going to talk a little bit about the offset. The offset is not brand new, but relatively new to Revit. A lot of people I see complain that Revit doesn't have an offset. I usually point this out to them and they go, oh, look, it does have an offset. That's awesome. However, we don't figure our offsets by angle. We figure our offsets by distance, and then the angle is what it is. All that being true, what we have here is something that's controlled by angle, and so we just have to use some due diligence and some deductive reasoning to figure out exactly what those angles should be. This thing is pretty flexible. Of course, if I highlight in here and I type in something like 45 to go ahead and adjust that angle, you'll see that angle adjust. But one thing that's really nice, I think, about this too is that you also have some throat control on each end. I can go ahead and increase this. I'll bump that up to 6, and I'll bump this up to 6 as well. You see that throat control appear here. Now, this geometry, as you see, just kind of stretches north and south. It doesn't necessarily stretch east and west, and the dogleg isn't exactly accurate as either. But it's something that we can use in Revit that's going to use our analytics and make your analytics a little bit more accurate than if you used one fitting, or excuse me, if you used three fittings to complete this, being an elbow, a straight, an elbow, transferring that all to one fitting. So come back in here and just kind of show you what we can do with this. As I click this guy, maybe I don't go to 45, maybe I go to 60, and you can watch that geometry stretch a little weirdly, right? If I ever hung that in the air, I think I'd get in trouble. So again, not accurate from a standpoint of geometry and fabrication, but if you're trying to run analytics and get some accurate analytics inside of Revit, this is going to get you a little bit closer than doing that with 3 separate fittings. Bring this back down to 30 for now. So there's the OG offset. Feel free to play with that and use that at your leisure, but it is something I recommend that you do look into, because it is a pretty usable piece inside of Revit. And then to wrap things up, the final little push here, I want to come down and take a quick peek at some transitions. Simply because transitions are one of those things that a lot of people just plug in and they don't give a heck of a lot of thought to. In Revit, there's there's several actually, different transitions that you can use for ductwork layouts. But these transitions that I'm looking at right here are going to be angle and length based. The angle based transition basically comes up with its length based upon the degree. So if it's 45 degrees, it's the length that it is there. If I increase that to 60, you see it shortens up quite a bit. But one of the things that I always like to point out about these transitions is your ability to offset that transition. So if I come into these numbers here and I say I want to offset the width, right now it's 12 inches, maybe I want to make it 6. And you'll see that it can go to one side flat. If you come back and you do top or bottom here, you can go to one corner flat if you'd like. So there's lots of different options. This is completely flexible inside of Revit. You could also say, for example, if you wanted to plug in an offset, you could do that as well. So if this was 6, let's make it 4. You can see that I plugged in a 2-inch offset into one fitting. Now again, graphically, this is a little lacking. This isn't as good as we need it to be. But from an analytics standpoint, this works, especially if you're going to be building it this way. This will allow you to get more accurate analytics, as well as kind of simulate more of a real world type of scenario. But of course, this can also go extremely awry, where if I set this to 0, that's something that we wouldn't be putting anything in like that in the field, obviously. But again, from an analytical standpoint, it does work a little bit. But that's the angle one. The length one I like to use simply because I get to get a lot more control out of it. And it looks like this one I plugged in as an angle. Let me go ahead and fix that really quick. Length base, thank you. And so when I'm using the length based one, I have options not just for the width and the height for the offset, but also the length. And I just feel like this one is much more realistic, simply because I can adjust that to be any length I want it to be, just in case I want to remove some joints or carry an offset. So if I come back and I say make this from 12 to 24 inches, we'll double the length of it. It's more than capable of doing that. Plus, it's more than capable of doing some of the offset stuff. So 6 inches there should bring us down to one side flat, and then of course 18 would bring us to the other side flat. So there's a little bit of math, a little bit maybe of trial and error here to get exactly what you want out of this fitting, but it is 100% doable inside of Revit. And again, this will make your analytics more accurate and make things work a little bit better for engineers. I'm going to go ahead and tag this ductwork. Now, tagging, actually let me tag this guy, because the slope's going to throw this guy off. When we tag this ductwork, we can use certain tags to take advantage of the information that's inside of Revit that a lot of people struggle with conveying. One of the things that we can do is elevation. I will go ahead and create typically top of duct and bottom of duct elevation tags so that we can track a lot of that. And so you can see that you can make tags here really quick that just go ahead and do your top and bottom of duct. This is a really good way to convey through tagging anyways a rise or a drop in the ductwork. A little bit easier than just having to put simple annotation by something to say, you know, down or up or top flat or whatever that might be. Tagging, using this tag just automates the process so that you can just go through and place this, obviously, like you just saw me do here. And then as the elevation of some of this stuff changes, that tag will update. So maybe I'll take this guy up to 7.4, and you'll see that that updates automatically. So again, just trying to automate the mundane and make things a little bit easier for you inside of Revit. So again, must apologize for the technical difficulties earlier today. I hope you guys enjoyed the webinar. Please feel free to check back with us with any questions. And since I wasn't able to take your questions live over the webinar today, I would encourage all you guys to go ahead and post your questions to this YouTube video, and then I will go ahead and answer those all independently and you know, get back to you as soon as I possibly can with the right answer. So once again, guys, thanks for attending, thanks for watching, and we'll catch you again soon. So have a great day, and yeah, keep on Reviting.